In this episode, we have Benjamin Bratton, who is director of Antikythera, which is part of the Berggruen Institute. He's also a professor of philosophy and technology and speculative design at the University of California, San Diego. Author of many things. It's much too long to actually catalog them all. But I'd like to ask you a good question, which is, what was it that attracted you to having Benjamin on the pod?
Well, many things, but probably the thing that really grabbed me is that I really love what Antikythera is doing. And I think it's an incredibly interesting project that he's undertaking, including the book that we talked with him about. But it's very, there's a lot of synchronicity really between how Antikythera is thinking about planetary-scale intelligence and how we're thinking about the artificiality in terms of the if you like, the increasing synthetic and symbiotic relationship that we have with synthetic intelligence. So there's a lot of crossover, and I find him a very expansive thinker, a wonderful explainer of things. And it's a very lively conversation. He also was able to recommend lots of little pockets of things that I found wonderful to dive into. Different scholars that I didn't know, different ideas that I hadn't come across that were just a couple of steps out from how we think. So very rich. Could have talked to him for hours, and this came from meeting him in person in San Francisco at a Long Now event. So it was sort of a natural progression to have a conversation today. Yeah,
I feel like it was very much the thesis of Antikythera and the thesis of Artificiality is intertwined in ways that's interesting. But I also found myself feeling like Benjamin is a friend of a friend, given the people who are coming to the Artificiality Summit in October in Bend. There's a handful of those people who are all connected very well, and it kind of feels like a community that's sort of amorphously formed.
Yeah, well, and
I found that to be really
certainly,
interesting.
I don't think that we've gone kind of mad saying that there's many paradigms sort of been under pressure in science at the moment, but certainly the discussion with Benjamin, who's able to see that sort of broad encompassing, what's happening in astrophysics and astrobiology and origin of life, and what's happening in paradigms of intelligence, and what's happening in synthetic biology and in biology overall. His mind at being able to do that interdisciplinary, and in the conversation we have with him, it becomes really clear that was not an overnight journey.
No, definitely not.
So great respect to him for sticking to the lonely life of true transdisciplinary thinking.
Okay, well, we'll leave it there and hope you enjoy our conversation with Benjamin Bratton. Benjamin, thanks so much for joining us. We're really excited to talk to you today.
It's my pleasure to be here. Thanks for the invitation.
So, as we were just chatting before we started, we were chatting a little bit about sort of your background and how you came to where you got to and some of those pathways. And I'm going to grab a word, I hope you're okay with me grabbing, is you described a little bit of it looking a bit like a platypus to other people. And there's something really beautiful about that. And I'd love to know a bit more about what inspired you to go down this path that makes sense in your mind, but to others might feel a bit like a platypus.
Yeah, let me perhaps explain for your audience a bit what I meant by that. And that is, I was saying it's oftentimes difficult for me to describe simply what it is that I do, what my disciplinary project is. Though to me, it feels really like one comprehensive project that I've been working on for 30 years, and it becoming increasingly synthesized and hopefully amplified in different kind of degrees. But to the outside, at least for a lot of those 30 years, it seemed to a lot of people as a kind of hybrid initiative where sort of bits and parts from different places that aren't usually stuck together form some kind of odd creature, a bit like the platypus, I suppose, in this regard. But again, it's more that it may look like a platypus from the outside, but it doesn't necessarily feel like a platypus from the inside.
help us understand how you describe the common thread that brings all of this together for you.
The work has really been for quite some time around the broader epistemic and practical philosophical implications of the emergence of computation as a planetary scale infrastructure. It took me quite some time to arrive at, I think, the vocabulary by which this could be properly articulated, but it was something that I had sort of been drawn to and from, for quite some time when I was in university, though had been largely frustrated by the academic context in which I found myself, which wasn't very receptive to the idea that things were about to be turned upside down in a fundamental kind of way. And so I was sort of forced to forge my own path in this regard. But that has been the kind of the common thread throughout a lot of the work, which, the book, The Stack, which came out and really written primarily, I would say 2012, 2013, hit the shelves in the very beginning of 2016, was really the culmination of 15 years of work that I have been doing, thinking about the implications of this dissolution of calculative reason into the material world around us, by which the things become increasingly capable of forms of not just information processing, but information generation, cognition, arguably, and the significant implications that has had and will continue to have for not only the built environment, but for the way in which we reflect ourselves in our environment, and how that those reflections come to constitute what we call culture. Since then, one of my current primary project is a think tank called Antikythera, which has developed, and quite nicely, into a kind of emergent school of thought, if you like, around this, not only this vocabulary, but this sort of set of concepts that, in ways I'm very appreciative of, has drawn together a lot of thinkers and scientists and writers and technologists with whom I have a lot of respect, who have enthusiastically, which I'm very appreciative of, organized themselves towards this project. I think that kind of the key idea that we might be developing, as it turns out, we maybe didn't know this when we began the project, is that we need to understand computational technology as something that literally evolves. And I don't mean that in a metaphorical or allegorical sense, like that it's constantly changing and that the iPhone 22 will be a variation on the iPhone 19 or whatever. But rather, many of the things that we're currently, really in the last 20 years, come to be focusing on in our understanding of biological evolution, the scaffolding dynamics by which systems become complex and therefore then become components in yet more complex systems, the dynamics of symbiogenesis, of exaptation as well as adaptation, and perhaps most importantly, niche construction. That is, the way in which a species not only fits into an ecological niche, but transforms its ecological niche. And because it has transformed its ecological niche, that niche now acts back upon it differently as a selection dynamic than it would have otherwise. And so that process by which a species artificializes the world is not separable from the process by which the world artificializes that species. It becomes a kind of cyclical dynamic. This, I think, holds true for more complex technologies that are the result of abstract human thought as much as it holds for primordial technologies. But today, computation is not only as an allegory, but really quite directly is the basis of the technologies by which we not only transform our worlds, but which we think our worlds, that allow us to understand and comprehend where we are and how we act in different sorts of ways. And so in this sense, computation has to be seen as a kind of fundamental mechanism by which this larger arc of niche construction, what I call allopoiesis, as opposed to autopoiesis, how an organism might internalize its external environment to internalize energy, information, and matter to remake itself. Allopoiesis refers to how it would internalize energy, information, and matter, or work upon it to produce an extrinsic system to itself that it uses to capture more energy and information and matter than it would have been able to do otherwise. And it's because of this capacity for allopoietic competence or allopoietic virtuosity that some species are able to grow and stabilize large populations. Now, to get really good at that, you have to become, the evolution of complex intelligence, including symbolic thought, becomes very handy to coordinate this sort of allopoietic virtuosity. Now, to sort of bring this back, as I indicated, at least for the last 50 years, which is obviously a kind of a blip, and not even a blip in evolutionary time, but the computation, which is, or what I would actually call artificial computation. I think we discovered computation as much as we invented it. But our artificial computational technologies have become the primary means for this allopoietic competence and virtuosity, which means that they are not only something that we use as a tool, they are something much deeper than that, much more fundamental to the process by which humans are directing, however blindly, the course of not only the evolution of other species, but indeed of ourselves.
You captured so much of and so elegantly there, so much of how we think about the shift that we're undergoing in our mental model of what evolution means.
Yep.
And that we're coming to understand and appreciate much more about things like, just even the concept of causal information in that kind of system. And it takes a while to get your head around, especially if, your schooling is very sort of that evolution by natural selection is somehow has to be a particularly passive process, and now we're moving to this world of causal information and different ideas of persistence and how niche construction favors persistence, which then favors niche construction, and it's this sort of bootstrapping and, as you say, scaffolding. How do you think about the idea of allopoiesis? How do you think about the introduction of artificial computation into that ecosystem and what makes it different than biological computation? Do you see a difference, or is the whole point that it's grounded in the same kind of mechanism?
I think some of the mechanisms are at least isomorphic to one another, and in other ways they're really quite different. I mean, the digital computational systems that we've produced, the logic gates, are relatively consistent. Biological computation tends to be much noisier, much more stochastic in this regard. But there are, I think, similar kinds of ways in which the two begin to operate. I think one distinction I would make, not necessarily between biological and artificial computation, but between computational technologies and those information technologies that have preceded it, is, as I suggested, they're, from the telegraphs to phone lines to writing to other kinds of things. We've developed a lot of technologies that allow us to encode information or to transmit information. And then much later on, it became possible to produce technologies that at a wide scale and with a great deal of complexity were able to process or even produce information. Computational technologies, part of what their novelty, perhaps, and their own capacity for a kind of evolutionary takeoff, is in the conjunction of all three of these into one, and their ability then, I think, to not only transmit or circulate information that is produced elsewhere, but actually to generate and respond to their environment in such a way that there is a kind of at least proto-cognition that's at work, means that they are not only a tool with which an intelligent species such as ourselves employs for purposes of our own allopoietic project and recursive self-artificialization, but they themselves are evolutionary actors. How forms of computational intelligence at different scales interact with the world around them. There are likely clear or isomorphs the way any other species might interact with the world around them. And where I see this going is right now we're thinking about, there's a lot of tendency to focus on large language models for reasons that are quite clear and profound. But one of the more interesting shifts, two of the more interesting shifts this year are one, a movement towards robotics, and the movement of not only applying large language models into robots, which doesn't seem to work, seems to hit a ceiling pretty early, but the development of specialized models, specialized operating systems for spatial intelligence. Many initiatives sort of at work that are sort of working with this profound way, some of which more multimodal than others. But what this implies is that Hubert Dreyfus's old critique of AI, that it's not embodied in the world, and therefore will never be able to develop a kind of tacit knowledge. It will never really be able to evolve beyond its initial instruction set because it doesn't have to deal with and accommodate and negotiate and navigate and be persistent in relationship to the constraints of an open world environment, which is how human social intelligence evolved in an open world environment. But in principle, that's not necessarily true anymore. That if you have a kind of inorganic species that is capable of, and again, it's not exactly like animal intelligence, but it's still significant. An ability to sense, model, process, predict, and recursively act upon its environments in ways that are again open-ended. That inevitably becomes an evolutionary process when you've got large populations of such entities coordinating and cooperating or even competing at large scales. And so the old adage of sort of AI as a kind of oracle in a box, or the chat, the mysterious oracle at the other end of the chat screen, begins to give way to a different kind of model. The other is the increasing interest in what is perhaps, which may be a bit apocryphal, agentic AI, or the construction of AIs that have a relatively higher degree of apparent autonomy, of working within systems in the world themselves. I think there's a longer discussion to be had here about really what the implications of large-scale populations of non-human, human-level minds might constitute when that ratio of human-level minds at 8 billion is outnumbered by 80 billion or 800 billion non-human, human-level minds, and what constitutes society or the space of social interaction, exactly who's constructing whose niche in this environment. But what ties these together in terms of our previous line of thought is that there's no way to really understand what's going on with the complex dynamics of those two kinds of dynamics of a truly cognitive, competent forms of robotics in the world, even at insectoid intelligence levels, but that certainly be more than this, that a large proliferation of synthetic agents that are acting deliberately, goal-directed ways, trying to solve a problem by means-agnostic ways in the old William James definition of intelligence. There's no way to understand the complex dynamics of these without looking at evolutionary theory, without looking at the dynamics of niche construction, of allopoiesis, of predator-prey relations, of social intelligence explosions, of power law dynamics in terms of populations, of different kinds of equilibrium models in relationship to different kinds of structures and species, and ultimately the production of new niches. And so this is why I would agree with your point, is that we have a tendency to think about evolution in the version that we still teach high school students is primarily a very Dawkins version of it, where there's a high degree of emphasis on natural selection and the agency of the genome, which is not, of course, not wrong, But I think there is quite clearly an increasing consensus that a version of symbiogenesis, not necessarily Margulis's version, but a version of symbiogenesis is undeniably not only something that happens in origins of life scenarios, but is part of how evolution continues. That the Nader, Smith, and Sothmari models of scaffolding and increasing levels of complexification is a fundamental comprehensive tool to kind of understand not only extrinsic selection pressures, but the constructions of complex information systems, and indeed the recursive dynamics of niche construction. These three together constitute, as you suggest, a different valence for what we mean by evolutionary dynamics, a different valence for what we might mean by social Darwinism, for that matter, where as opposed to it being a kind of Herbert Spencer survival of the fittest scenario, it's something that's much more cooperative, much more adaptive, that looks more like a complex adaptive system rather than a knife fight, and is something where those recursive dynamics between inner world and outer world, between organism and species, between species and environment, are ones that are characterized more by internalization and externalization than by competition, and certainly characterized by varying velocities of feedback loops, let's say. And so, it may also, in certain respects, cybernetics makes a comeback every 10 years. It sort of goes away and comes back, and it may be due for yet another comeback in this regard. And I think we're up to sixth order cybernetics now after Brev. So that may be what we're looking at here as well.
I want to go back to the points you were making on spatial intelligence and embodiment, and it's natural for humans to think of spatial intelligence and embodiment in our own way, right? So we see the construction of robots that have 2 legs and 2 arms and 10 fingers because that's the way we think of it. We think about our relationship to space and our spatial intelligence and what that does for our capabilities for abstract reasoning and thinking about it from those perspectives. If you can break free from that a little bit, I'm curious to know what you think is important or maybe required for synthetic intelligence in terms of its ability to make sense of space and its actual embodiment. Like what portions of what we understand embodiment is important, but also what might there be in terms of spatial intelligence and embodiment that we don't have or don't understand as humans, but might be important to a synthetic intelligence?
It's a wonderful question. I think you're right. I think there's always been a kind of projective, not only skeuomorphism, but anthroposkeuomorphism in our relationship to robotics, where we make, and you see this with the development of many humanoid robotics now as a kind of replacement structure of this as well. And to some extent, this has to do with, as you suggest, a kind of default presumption of what intelligent embodiment in the world looks like. And to some extent, it has to do with much more prosaic dynamics of if you're going to replace a worker on an automobile assembly line, it's cheaper not to have to redesign the assembly line. And if everything is designed to be exactly 4 feet tall and you're looking down on it, like you make a machine that takes that fits that niche. The niche that happened to have been constructed originally by the outline of the human diagram. There may also be ways in which the tetrahedral body plan was a kind of an overdetermined solution to evolutionary problems. It's probably a matter of some ultimately metaphysical kind of debate as to how necessary the arrival of the tetrahedral body plan as a kind of functional diagram for terrestrial life must have been for it to work. I would probably come down a little bit more on the side of path dependency there, that may have been a little bit more inevitable than chance in this regard. And so perhaps there are other just functional adaptive reasons we might arrive at certain kinds of corporeal diagrams for topologies for a robot that look animal-like because this works as a kind of solution to our particular gravity well and how horizons work and the rest of this sort of thing. For sure, mammals in particular, have certain affordances and certain limitations in terms of, we condense all of our sensory organs on the front of our skull, which allows for a lot of forms of efficiencies in information processing and such things. Lots of other animals don't necessarily do that, and certainly an artificialized inorganic species doesn't necessarily need to do that either. And so a couple of the ways in which we might think about a different kind of evolutionary trajectory for the synthetic species that we're making now. One may have to do with a kind of decoupling between the sensory capacities of the organism and the species and the information or processing or cognition capacities of the species. I see through my eyes, and my visual cortex processes what I see through my eyes, and there's a tight coupling between these in a sort of way. But in principle, there's no necessary reason why robot A could not be seeing through the eyes of robot B seeing through the eyes of robot A when the situation calls for this. There are sort of boring everyday examples of why it might be a good idea for my car to be able to borrow the line of sight of the car on the other side of the intersection so I can see whether I've got the right of way for a moment, where there becomes a kind of a sensory swapping within a population of species so that they can converge with each other in different sorts of ways. So, at a much broader level, you can imagine an urban landscape in which there are however many million of sensory input points that are visual, that are auditory, that are thermal, whatever, and that these are shared by perhaps hundreds of forms of synthetic intelligence that at different point in times might connect to different kinds of sensory mechanisms in order to accommodate and navigate the world around them. So I think one first thing to think about is this decoupling of sensing, body, and cognition in ways where the robotic species we make may look a lot more like sophonophores, the undersea animals where they sort of recombine into different configurations and shapes. The other one has to do with, we are, despite our, some people's ambitions to move a lot of people to Mars, we are really, really dependent upon and really closely adapted to the environmental, atmospheric, ecological conditions of Earth. And we are really fragile apes that you move us out of any of these, put us underwater for 2 minutes, we're messed up, put us too far in the sky, we're messed up, let alone putting us on a planet without an atmosphere for too long, right? The fragility of us as highly niche-dependent mammals requires any sort of movement out of a relatively narrow band of our planet, the potential space of planetary and extraplanetary movement, is one that requires the construction of total artificial environments that are filtering ultraviolet rays, that are processing air, that are processing liquids that become us, and so forth and so on. And this comprehensive artificialization of our all of the niches in which we're suitably adapted and all the ecological functions upon which we're dependent is highly complicated and highly expensive. But it also, it demonstrates that, we are, as a species, we are the result of all of these mechanisms around us. We are inseparable from them. We are ultimately deeply dependent upon all those niches rather than the other way around. But none of this is necessarily true for machinic species, which can, in principle, operate. They have a different relationship to, solar radiation, ultraviolet radiation. They can see different parts of the light spectrum. They can think much slower at sometimes as needed. They can think much faster at other times. Their potential relationship to different differential forms of gravity is quite different. We've built some in the shape of submarines that are just fine for going underwater for longer periods of time. And so the reason I bring this up is that I think this is a sort of, whether we go to, whether you think about this in terms of outer space or not, the key idea is that there are forms of ecological adaptation and intervention and inhabitability that other forms of synthetic species may be much more capable of, much more competent in than we are. And, at least for a while, it's possible to see these as a kind of prosthetic species, right? There is, of course, a planet in our solar system inhabited entirely by robots, that is Mars. And, we celebrate, we lose our minds when a human lands on the planet, but no one can even remember the name of the Chinese robots that are on Mars as they're walking around. We don't see them as creatures. We see them as machines. We see them as prosthetic tools that are there as well, and for obvious and probably good reasons as well. But once I think a kind of complexification dynamic starts to take off, that becomes less tenable. And so this is, I mean, sort of the horizon where I think this goes. But the key answer to the question is, one, there may be very good reasons why we arrive at the same kind of body diagrams, because they're adaptive to certain kinds of niches, and certainly adaptive to the artificial niches we've constructed for them, like an assembly line. But at the end of the day, it's quite possible to think about the composition of forms of species that can evolve and adapt and indeed inhabit for long term, sometimes in conditions that humans would be unable to do so. And in doing so, this arguably extends the footprint of what it means to be an Earthling.
The way you describe it is like life as a technology itself.
It could be. This is a discussion I've been having with two people, one, Blaise Aguirre-Arcas, who you've had on your show, I know, and Sarah Imari Walker, who I just did an event with at the Long Now Foundation. They come down on different sides of this question, but there's certain ways in which, primarily to do with the role of computation. But there's certain aspects of this where I think they agree, and certainly ways in which I agree with sort of parts of this as well. I've come to the conclusion, and I'll sort of start with the punchline here, that as we're seeing a kind of direct physical convergence between many of the things that we might have in a sort of Aristotelian categories, may have defined as that is life, that is intelligence, that is technology. As these things as things that exist in those categories, conventional categories, begin to converge in things like AI or synthetic biology, like is synthetic bio life or technology? Yes. Is AI intelligence or technology? Yes. It is both. That what we're beginning to see is that the most contemporary definitions of what life might be, and Sarah and Lee's assembly theory is I think case in point here, and the kind of definitions of intelligence that we might have, and I think Blaise is exemplary here, and the kinds of definitions of technology that people like myself might be developing start to look more and more similar. That all of these are kinds of complex adaptive systems that make use of an external environment for some kind of goal-directed way, for self-sustaining based on kind of anticipatory or predictive dynamics, that they're constructed through time, through a kind of regularized scaffolding process by which what adapts at one moment becomes a component for what exists later, which may be a bit of a mirage of the moment. But it may also suggest something more profound, and that is that the things that we identify as life, intelligence, technology, not that they're all exactly the same thing, but they may be different manifestations of a kind of more general or universal dynamic that we are just beginning to sort of wrap our heads around, that has made each of these kinds of instantiations, which are obviously quite both similar and different from each other, possible in the first place. I think it is, to your specific question, I think it's certain that life uses other forms of life in a technological way. It's really hard at the end of the day to make an argument that ribosomes are not a kind of technology for the making of proteins. Like, it's hard, the more you understand about the dynamics of cells, and we're really still obviously scratching the surface, it's really hard to think of RNA not in technological terms. But that becomes that distinction between, is this life using technology, or is this a demonstration that some fundamental aspect of life is itself technological in some way, where we would have to expand our notion of technology beyond tool being but it is certain kind of capacity for allopoietic dynamics that are self-sustaining in some sort of way. And it gets fuzzy and it gets tricky and it gets a lot of issues around kind of semantics. And I think more likely that the way out of that fuzziness is not to continue to argue about which Latin word we should use to describe each of these phenomenon, but probably to invent a more rigorous and empirical glossary, a better terminology to describe these kinds of things. But to answer your question very directly, I'm not sure if life is a technology, but I'm certain that forms of life are technological in terms of their relationship to other forms of life, and that life as we know it cannot emerge other than through dynamics that as Blaise would recognize as computational dynamics, that Sarah and Lee would recognize as a kind of scaffolding structural dynamics, in the way I would recognize it, at least both intrinsically and extrinsically to those living biological dynamics, as one in which biology uses other biology as a technology to make itself, and that's not the exception, that's the rule.
Yeah, I was trying to unpick the difference that I thought between Sarah and Blaise, and I'm not sure I can completely categorize it. And then I wonder if one of the reasons I'm not sure I can is because we are missing so much vocabulary for this, that how we actually grapple with the words matters. And I was interested that your choice of going from autopoiesis to allopoiesis unlocks such a different mental model. It was kind of the same unlock that Peter Stirling had when he went from homeostasis to allostasis. It broadened the entire, and it was actually his book that kind of started us on this whole crazy journey of way back when. We had the spatial discussion. I'm really curious about the agentic discussion. Sure. We met you at the Long Now Foundation,
yes,
with Sarah's talk, and she said a couple of times in that talk that as we get more sophisticated, as quote unquote any kind of planetary civilization gets more sophisticated, more technological, that we become more virtualized, I think was how she described it. And I'm curious about how you see the virtualization of our cognition and our experience kind of coinciding with with these increasingly agentic systems. And if we have, I don't know, 80 billion sounds like a tiny number. 800 billion sounds like a tiny number. Maybe it's like 8 trillion agents. I mean, Mark Benioff wants to do 1 billion by the end of this year. So there could be this explosion of agents that it doesn't matter that how they're using language anymore. What matters is what their own spatial reasoning is inside of a virtual environment. Like, how do they form that virtual spatial reasoning, and how do they convey meaning to us? How do you think about that more virtual niche construction?
It's a lovely question. I don't want to speak too much for anyone else, but I think just to pull on the thread of your point and to agree with the point is that the way in which Sarah means virtualization is rather different than the way in which, say, David Chalmers might mean virtualization in terms of virtual reality, or Deleuze might mean virtualization in terms of the plane of immanence. Roughly speaking, what she means is that as the objects that are assembled, that assembly index might model, become increasingly complex, they become increasingly something that can only evolve through the deliberate planning of a concept that would give shape to them in advance, and through the coordination of concepts between collaborators that can understand and model this thing and to instantiate it in itself. And so that object begins, the 747 or the iPhone, begins first as a concept that is instantiated in the object itself. And for her, the history, the chain of causality of that object has to include that causal, the virtualization that in fact gives rise to it.
So, for example, just to jump in, So the next word that Silicon Valley might break is imagination, because that becomes like imagination is in that realm a virtualization of a concept.
Didn't Disney already?
I'm trying to think that some math behind it. We'll have an equation for imagination.
Oh yeah. Yes. I hope not. I think one of those things that there's certain things that are lend themselves to measurability, and certain things that don't quite as well. But to your question about agentic dynamics of this as well, like and whether or not those ratios hold in one way or another, the way in which we tend to think through these problems, Antikythera and myself, is usually a bit more first principles, and sort of building out from there. I think with the presumption that people are, for good reasons, focused on relatively short-term cycles and dynamics of, like, there's a relatively immediate opportunity to be captured and to be fulfilled. And what Salesforce, as you mentioned, might be doing with agents is it will contribute for sure to the ultimate, to the evolution, either through success or failure, to the evolution of these at scale. Probably not as much as some of the vibe coding tools to let you make your own agent will, but that's another conversation. But that's not really where we start. We would sort of start with the question of what is it about the dynamics of agency itself that are put into question by the hypothesis, the virtual concept, in advance, if you like, of wide-scale agentic AI. How does this reflect back to us a different understanding of what agency might even mean, particularly in relationship to subjectivity? And this can go in a few different directions. Like, I would argue that, as I've made the point many times, when people ask the question, what does planetary computation have to do to contribute to the mitigation of climate change? We need to first understand that the only reason we understand the climate is changing at all, the very scientific concept of climate change, is an epistemological accomplishment of planetary-scale computation, supercomputing simulations that tell us so. And so all climate politics is at its core an attempt to build a planetary politics around the potential implications of large-scale computer simulations. Which is not the way, Greta Thunberg might think of it, but that it's nevertheless the case. But what that also implies is that humans have been transforming, subset of humans, or all humans, depending on how far back you go, have been fundamentally transforming their environment at a terraforming scale long before they knew that they were. And so agency long preceded subjectivity. Agency preceded subjectivity. It's only recently that the comprehension of, like, the capacity of a subjective awareness of this agency comes about through climate science, at least centuries after the fact that this agency comes into play, which is not the way we teach, agency within an ethics program at a university, which is usually you calibrate your subjectivity. And by calibrating your subjectivity, this will manifest in your agency in such a way that the dominoes that cascade from you will be the good ones because of this calibrated subjective core. But if agency precedes subjectivity, what then? This, I think, has implications for how we think about agentic AI in at least a few ways. One is this. The way in which many of the more conventional, but even less conventional discourse around agentic AI tends to play out at this early moment, and just obviously change very, very quickly, is that agents are, in essence, imprinted simulations of the humans that they are acting on behalf of. So I might have an agent of me that I send to a meeting, and you may have an agent of you that you send to a meeting, or the owner of a factory may have an agent that is replicating the agency of that one worker that does a particular thing on the line, but that the agency, and indeed ultimately in some contexts even the subjectivity or apparent performance of subjectivity of that agent, is a unidirectional imprint of the human, the Vitruvian human from which they originate. I think in the early phases of this, that's likely to be the kind of dominant dynamic where, there's a kind of production of lots of copies of the human original. I don't think that's going to hold for very long, both in terms of the way in which the dynamics of agency and the dynamics of subjectivity. If, for example, Benioff and others are right that it's not just that you're going to have a agent replace a job, but you may have 500 agents working in a job because they can not just red team and blue team a problem, they can, all 16 million colors of the visible parts of the light spectrum teams could be working on this kind of problem. But what this means is that as you or I become someone whose our agency in the world is mediated and manifested through an increasingly plural and growing ecology of doubles of ourselves or versions of ourselves acting in the world, people come to see us in a more plural way. Not because our agency is multiplied and pluralistic, the social imprint or reflection of our agency in the world from others becomes more multiplied and pluralistic. So I don't just become the things that I do, I become all the things that are done through this sort of virtualization of my agency through this multiplication dynamic. Ultimately, that has to do not just the way in which others see me, but ultimately the way I see myself. That instead of a unidirectional dynamic between I'm the original and it's the copy of me, like looking in a mirror, well, when the mirror starts talking back, something changes. You end up having not just you and your shadow, but you end up having what amounts to a kind of parasocial relationship with yourself or with versions of yourself in which the feedback loops of reflection, of subjective reflection in terms of who you are and where you are becomes more multiplied, arguably more fragmented, more complicated, certainly. And in this sense, very quickly, this model by which you have a kind of core of agency that is simply virtualized and radiated downward, everyone a little vice president of all the different robot versions of themselves, gives way to something much more complicated, in which not because the agency is multiplied and pluralized, because others see it multiplied and pluralized, that we are presenting ourselves in this way externally to the world. So our social being becomes multiplied in this way. But ultimately the way in which we see our own agency and therefore see our own subjectivity becomes fragmented and multiplied in different ways as well. That's a very different kind of niche construction. It's a very different kind of allopoiesis, but it's one in which, I don't think Salesforce is really the right people to help us negotiate that world in many ways. And so it requires nothing against Salesforce. I'm just saying it's not their job. No. But it is it nevertheless is, part of the kind of reason why programs like Antikythera exist, because, all of these sort of extent versions of this are usually ultimately built upon foundations that are less apparent, emerging realities that are sometimes less apparent, and things are always much more complicated than they seem. And if one of the fundamental dynamics of complex intelligence is capacity for foresight, I think that's something we need to, a muscle we always need to continuously exercise. But I hope I've answered your question a little bit about that relationship between agency and virtuality. It works in at least two dynamics. There's a way, in the Walker sense, there's a way in which there's a kind of conceptual dynamic that becomes manifested in real instruments in the world. And so the reason the agent is the way it is because you had an idea for it that becomes materialized in the thing. And so it's a kind of noospheric projection, if you like, into these dynamics. But there's also the dynamic of virtuality in the sense in which you at the core of you becomes virtualized into this army of shadows that is acting on your behalf, such that it ultimately becomes less clear which is the original and which is the shadow. I think we all may very well come to have to, understand ourselves as the shadow of our agency rather than our agency as the shadow of us.
I find it interesting if you take that shadow and you give the shadow the capability to do things that we can't do. right? So you're talking before about having a car that can communicate with the car across the intersection to be able to see whether you got the right of way. I'm just going to highlight this book, The Planetary, and your essay in it, which I won't try to represent at the moment because I don't think that's quite fair for me to try to do that. But the mind wandering that it caused for me was stopping and thinking about the planet as not the natural thing that we kind of think of as the planet, but this combination of natural and synthetic, and that it's wrapped in this world of intelligence and all of these satellites that are traveling around, and all of these changes that we've affected in our world that we can't, as our own embodied selves, tap into directly, and in some ways we can't tap into at all. But a shadow of us, or even if you're not going to go to a completely independent, AI agent, that is constructed, but if your shadow could suddenly be, tapping into planetary level, scale intelligence, it creates a kind of mind-boggling, way of thinking about one of our core questions is around, people talk about consciousness and machine consciousness, and will machines become conscious? And I'm really fascinated with the idea of what could a machine help me be conscious of that I'm not conscious of myself? How could it extend my experience? And so the way that you're thinking about these, broadening and plugging into seems so, physical and anthropomorphizing, but the ability to tap into the planet in a way that we can't extends ourselves in a way that I find to be fascinating and hopefully really cool and weird in a good way, and not scary and, in a bad way.
Well, things can be cool and weird in a good way that are scary too. Like these aren't mutually exclusive. But yeah, I think I like the point. But just for your listeners I'll tell the story. That article begins with a parable, and that is, if we were to imagine the blue marble image, the 1968 picture of Earth in space, not as a static image, but as a movie, a movie that if you would watch the entire 4-point-some billion year evolution of the planet, and you were watching it, thankfully, on some kind of super hyper fast forward, what you would see is, a red planet turning green and then turning blue and the rest of it. And the continents move around, but the very last seconds of this film, you would see something extraordinary happen. You would see this planet sprout this crust of satellites and fiber optic cable and different sort of systems that extend beyond its atmosphere into different orbital levels. This organism, to take Brand's sort of metaphor for it, grew a sensory layer, that it was able to produce and relay information about itself to itself from this sort of quasi-allocentric perspective, or it grew sensory tendrils to sense things, but generally internal sensing was sort of its focus. What this suggests is that what we recognize as planetary computation and all of this kind of infrastructure is not just something that humans have done; it's something the planet has done. That it needs to be understood within the evolutionary history of Earth, that there is at least one planet that we know of that has produced, that has artificialized produced a new capacity for its own sensory awareness, information processing. There may be others, but at least one we know is capable of this particular evolutionary feat. Now, in terms of the tapping into this, I think there's something to what you're saying, and I think it's interesting that Dennis Hasiba's kind of bet on games was going to be the big path to AGI. Everyone had a different sort of path on this. The game that wasn't a bad idea, but but the fact that it turned out, at least for now, to be language, it may be other things later on, but it may turn to be language. Maybe isn't so surprising in retrospect if we understand that sort of language was the key to getting really good at the coordination aspects of collective intelligence. And the coordination aspects of collective intelligence are really important in terms of getting good at allopoietic virtuosity. And so on. That language, this repository of semantic intelligence, of sort of infinitely combinable forms of projective, descriptive, predictive, counterfactual co-intelligence Like, there's no point in having a language if others don't speak the language. And so language is by definition a plural function that of which each of us is a node. And so the scenario you describe, in which you or I, and we do this every time you read a book, or you go to the library, or certainly, when you're plugging into a kind of repository of collective intelligence beyond yourself. But the fact that I think we all have had some experience with using large models over the last year or so, where we have a kind of holy shit moment, where we feel as though that there's a kind of curiosity accelerator at work in this dynamic, that there's the capacity to sort of follow a line of thought, to become instantly competent in something that you may not have been able to do so before. For example, coding, recently of this as well, by which you can, this sort of initial experience by which I wish I knew how to think about this, or I wish I knew how to do that, or I wish you could think this through sort of in a kind of dialogic social way. And that becomes a general purpose utility, is something that I think is potentially quite profound in terms of the evolution of language itself, right? I also find it quite interesting, perhaps surprising actually, that even though language turned out to be such an important aspect for this step, that linguistics as an academic discipline is generally pretty pessimistic about all of this. You have, people like Emily Bender, but others who basically say, oh, it's not real, this isn't really language, this is something else, language, it's all bullshit, blah, blah, blah. Well, it may not be the language that Emily Bender thought language was, but the fact that language turns out to be, now language is anything that can be tokenized, that's tokenizable. The fact that language turns out through its self-artificialization, the language turns out to be something different than what language thought language was, is really interesting. And I think it inevitably will have sort of feedback where it changes not only the way we think about how we use artificialized linguistic systems like LLMs, it'll change how we understood really what was going on all along with the evolution of natural languages, and what kinds of nodes we really were, and what kinds of dynamics of collective intelligence were at work there, that may have been hard for us to see because we were the fish in the water. We were the fish in the water at that time. And so, I'd like to be, what you paint is an optimistic scenario, right? That there's some kind of noosphere accelerator dynamic at work here. And I would tend to come down on the side of making intelligence a general purpose utility in the long run has to be a good thing. That, one of the ways I think people aren't necessarily should be looking at this, but aren't, is that the training of large models is essentially a kind of consolidation of the professional wisdom and techniques of a relatively small section of affluent global society, and a capacity to make that expertise generally available to others who, for reasons of artificial scarcity and the history of human societies, haven't had access to this in different ways. The fact that I don't need a lawyer, or if someone in Argentina doesn't need an American lawyer anymore either. For an example that I happened to be dealing with last week. Another way we may come back to look at this is that the training of LLMs and the transposition of LLMs into essentially the means of production available as a monthly subscription or for free for some form of models will be the largest transfer of intellectual capital from the global north to the global south that could have happened during this time by this transference of general intelligence as a kind of construction. I think in the long run, that the power law dynamics of the activation of the whole of human society, and not just relatively concentrated segments of it that are protected by the history of the 19th and 20th century and by forms of artificial scarcity of those expertise, will be a net positive for everyone. It's going to be a bumpy ride in the meantime. But this is the paradox, though, and maybe this is kind of the concluding point in some respects. It's certain that in the short term, the capacity for complex intelligence was evolutionary effective and adaptive. that species that were really good at complex abstract intelligence had clear advantages over species that did not. And, us, these fragile, slow, puncturable, upright apes did well because of this capacity for complex abstract intelligence and the coordination dynamics that allowed us to, produce allopoietic systems upon which we depended from the very beginning. What's not clear is that if in the long run, complex intelligence is ultimately evolutionarily adaptive, or whether it may burn itself out. Is there a point by which the increasing capacity for the sort of self-amplification dynamic of increasing capacity for complex abstraction, I mean literally at a planetary scale, burns itself out in some kind of way, right? And I think part of that paradox might be seen in the, part of the existential impact of climate science and the discovery of the Anthropocene as such. And that is the irony that, humans they became aware. You're talking about consciousness of what? We became aware of that terraforming scale agency at the moment through the process of discovering that terraforming scale agency was potentially destroying the substrate upon which it depends for its future viability and from which it evolved, right? And so the cost of this enlightenment was the realization that the evolutionary process from which this enlightenment evolved is the cause of the thing that may extinguish this enlightenment in the first place. Yeah? This is the paradox of intelligence, let's say. And it's one that doesn't have a simple answer. I don't think the simple answer is complex intelligence ultimately adaptive? But I think what are the preconditions that would ensure that it is? What would make it adaptive? What would be those preconditions? And how do we deliberately bring about those preconditions such that, this isn't the end of the road? Modern humans have been around for 150, 200,000 years, depending on how you measure it. It'd be nice to think we're, no more than halfway through the curve. It'd be nice to think we're sort of at the beginning of the cycle. But if that's the case, then I think we really need to be thinking hard about what the preconditions for that possibility really are.
Fascinating. I mean, we could go for hours here.
We could go for hours, but we can't today.
Yeah, it's this idea of a paradox of intelligence that if we're scaffolding, if our abstract ideas are part of, it's almost like pulling us into the future of this causal information, then it shouldn't just be the technologies of construct. It should also be the mechanisms by which we engage in them that we start to think ahead. So if you're an AI safety researcher, you're thinking about, well, what are the things that make this safer? I mean, that on one level, that's sort of a no darn obvious, but it's actually not obvious to think about how agency precedes subjective experience, and how can you pull that subjectivity forward, if you like, so that you can see the consequences of the agency, which is kind of the point of what we're starting to do now. And I love hearing how maybe we'll think much more deeply about what language actually is, because there's such a tendency to now with the large language models for people to sort of dismiss a type of intelligence because it's only about language and it's not about other representations of theory of mind or spatial reasoning or whatever, but that there is actually something like really quite profound about that. So, yeah.
Well, I think I've got more questions for you now than I did at the beginning, which says a lot about the quality of the conversation. But thank you so much for joining us. This has been a true pleasure.
No, I'm a fan of the podcast, so it's a pleasure to join the conversation. Thank you for the invitation.
Thank you. Well, we look forward to the next time we get a chance to talk. Thank
you
so much.
So do I. All right, speak to you soon.